this session I have covered before, I think during the MCO time. Yeah, during the MCO time, but then it's just a repeated stuff for me to recover again, to recap again on this particular topic, session 4, guidelines to perform measurement invariance. So yeah, so when you talk about assessment of measurement invariance, I think these are the few articles that you can read. Okay, on top of that. So what is actually measurement invariance? In session 4, measurement invariance is a process that it's very important for you to perform first before you actually look into multi-group analysis. Okay, multi-group analysis is like you assume you do a moderator, you do a moderator and moderates all the relationship using categorical variables or dichotomous variables such as gender, age, and so on. So before you do so, you need to check on measurement invariance. So the goal of measurement invariance is to ensure that measurement models conducted under different conditions, which is like, for example, just now I mentioned gender, male or female, yield an equivalent representation of the same construct, which means your different respondent will feel that the question that you use, to ask their perception, they have the same thought in terms of the question. Same thoughts here doesn't mean one tick like a scale 5, one tick like a scale 1. Okay, same thought here is the item itself. They understand the item in the same thought and same manner. Okay, that is my explanation. According to Hart et al. 2008, if you fail to establish measurement invariance, it could be a potential source of measurement errors. And this is a very big issue because it will affect or influence your statistical test of hypothesis, and it could provide a misleading results. And according to Henseler 2016 et al., a lack of measurement invariance suggests that the composites carry different meaning across the groups. For example, male and female, which I explained just now, which may be a misleading source of structural coefficient group-specific differences. What does it mean? Maybe male and female, you could, cannot really see it, but in terms of, let's say, nationality, right? In terms of nationality, Malaysia will have different type of understanding towards a language compared to maybe US, right? For example, in Malaysia, we always like to, mention this word called thanks a lot, right? Thanks a lot, right? Our understanding of Malaysian when we say thanks a lot is like we are very thankful to you. But when you use this word thanks a lot, like for example, this is a question A, and you use the word thanks a lot, and you use it in US or European side, or maybe US, okay? US, I think US. This could be thanks a lot, this word, for them, in their meaning, could be sarcasm, okay? Sarcasm means that it could be thanks a lot, but indirectly to tell you that I'm not thankful. So because of that itself, that's the reason why people want to test measurement invariance. Because thanks a lot, this word, for me, thanks a lot could be I'm very thankful. But for US or European, it could be sarcasm, where thanks a lot is actually I'm not thankful, something like this. So therefore, you need to check on measurement invariance. Why? The measurement invariance here is to see whether how people feel about the question, whether they have the same thought, same perception towards the question itself. Doesn't mean there's no difference. There is a difference, but then it's about the understanding towards a particular statement or language from your survey design. So I'm going to skip this part. So when we talk about measurement invariance, in PLS, we have this famous technique by Henseler et al. 2016, created this technique itself and his colleague on MICOM. MICOM stands for Measurement Invariance of Composite Model. When we talk about MICOM, it goes through 3 steps. And when we talk about the 3 steps, let us start with the step 1. Step 1 is called Configural Invariance. Okay, I'm going to explain what are all these terms it's all about in detail later on. So step 1 is about configural invariance. You need to pass the configural invariance in order to move to step 2, which is compositional invariance. Once you pass compositional invariance, then only you can move to step 3A and 3B. And step 3A, 3B is actually the same step that look into equal variances as well as equal means. Okay, what does all this about? Okay, before I explain what all this about, You just need to know that when in PLS, you need to at least perform until step 2. Why need to at least perform until step 2? Because when you achieve step 2, then we can strongly claim that you achieve partial invariance. When you say you achieve partial invariance, then you can move on with your technique called multi-group analysis. But if it's best, you need to at least fulfill more than that, if possible, equal variances as well equal means. Okay, if you can do that, then you can do pool data. A pool data means you can actually perform the data better. But if step 3A and 3B, either one fulfill, then we also mention this as partial invariance. But if both fulfill 3A and 3B, then we call it full measurement invariance. So there are conditions for you to know, but minimum you need to pass is just step 2. If you can go further, step 3A and 3B. Okay. So what is configural invariance? A configural invariance, when you want to do a multi-group, when you want to do this measurement invariance, the step 1 configural invariance is about checking on your model of group 1 compared with model of group 2. What we want to check of model of group 1 and group 2, we need to ensure the item that you retain from your first model and your second model must be the same. For example, in this model figure that I show you right now in this slide, we have X1, X4, X6 for your first IB. That's the item. For the model group 2, you have X2, X3, X5. In such a case, there's a contradiction between the two models. If you have contradiction between these two models, you cannot compare the group. You cannot compare the group in the later stage for you to do a multi-group analysis. So in such a case, the item and the model retained for both groups must be the same. And this is the first criteria of configural invariance. On top of that, you need to also check on the data treatment. Your data treatment of first group must be equal with the data treatment of second group. And this is also the same for the algorithm setting or optimization criteria that you use in group 1 must be equivalent with group 2. And this is also same with the identical construct orientation, which means the construct that you use must be the same, the item that you use must be the same. If it's not the same, then you cannot compare. It's like talking about, it's like, we are looking into comparing apple to apple, not apple to pear. If you compare apple to pear, of course there's a difference. So in order to make it same, we need to compare apple to apple. So this is the first step that you need to fulfill, configural invariance. The second step is about looking into the compositional invariance. And this compositional invariance is established when a composite score, this composite score is come from the latent variable score that you run your PLS algorithm, as created by the weight from the first group, do not differ from those in the second group weights. For example, when you have a weight score, for example, you have satisfaction construct for group 1 and you have satisfaction construct for group 2. So these two itself have a score. When you run a correlation of this score, which is this score called composite score of these two groups, satisfaction 1, satisfaction 2, group 1, group 2, when you run a correlation to it, they must be equivalent. If they are not equal, cannot be compared. When cannot be compared, you stop here and you cannot do multi-group analysis. So therefore, in step 2 itself, compositional invariance need to fulfill. If can, C stands for correlation. The C must actually equal to 1. 1 means they are almost perfectly correlated between group 1 and group 2 for the both construct of like satisfaction, which the example I use. So therefore, to run this step 2 compositional invariance, Henseler et al. 2016 have proposed using a non-parametric test, which is called the permutation test, which I'm going to show you all in a particular short while. And we need to make sure you fulfill this step by ensuring your hypothesis is rejected. What do you mean hypothesis rejected here? What we want is there is no significant difference between two groups of the construct score or the composite score. Again, we need to make sure that's not significant. When it is not significant, means there's no difference. No difference of what? No difference of the two groups for that particular variables, there's no difference. When there's no difference, then only you can compare the multi-group analysis. And when you fulfill this step 2, this is where we call it as partial invariance. Okay. The permutation test of this compositional invariance is somehow like this, okay, in this slide, where you have group 1 of people, okay, group 1 people got respondent 1, 2, and 3, and 4 on your left-hand side at the top, okay, and the bottom side, you have group 2. Group 2 is your respondent 5, 6, 7, 8. And each group 1 and group 2, you have two different models. In two different, no, you have the same model, but they will run with different observation, different respondent. So when they run, they do a permutation test using MICOM. When they do a permutation test, they will permute the observation randomly. When they permute the observation randomly, which means that each of your respondent will compare among to other group. Okay, each of your respondent group 1 will compare with group 2, and they will see how close the correlation of the composite score from group 1 and group 2. If there's, when they run and get not significant, mean there's no different. No different of what? For example, Y1 and Y1 group 1 compared to Y1 group 2, there's no different. So when there's no different, then compositional invariance achieved. Okay, so what we want is they will run permutation many times to see whether there's a difference in terms of the correlation of the composite score. This is what step 2 do. Okay, so what we want is the correlation to get as close as 1, and what we can tolerate is like 95% confidence interval and 5% the correlation error and so on. Okay, so we move into step 3. In step 3, it called equal variance. Equal variance here, we use the the formula of log. Log of what? Log of the particular score. In the composite score that we achieve from the PLS algorithm or the permutation, it will then check on the variance of it. Variance of group 1 and group 2 for that particular construct. And when we check on the variance, what we want is the variance of that particular construct. For example, you have satisfaction construct and satisfaction construct of group 1 and group 2. What we want is we check on the group 1, group 2 for that satisfaction construct to see the variance. If the variance are equal, they are the same, and there's no difference, which is equals to 0 because they are the same, then step 3A achieved, which is equal variances. And in step 3B, which is equal mean, I think I need to do some changes in the slide at the top. The step 3B is about mean. Since we have both score of composite score for the satisfaction, besides checking variance, we also need to check on the mean. When we check on the mean, we also need to make sure group 1, the mean construct score, and the group 2 of mean construct score, they must be the same. If they are the same, then you achieve. If the 3A and 3B achieve, which is equal means and equal variance achieve, then we can actually assume and claim as full invariance. But if you only stop until 2, then partial invariance. The last condition will be if you pass step 2, now you move into step 3. 3 got 3A and 3B. When we talk about 3A and 3B here, if either one pass, one fail, then we also claim as partial invariance. So I hope you clear with this. Okay. So what does PLS does in measurement invariance? Of course, step 1, we need to check the configural invariance. We need to make sure the group 1 and group 2, they are the same. The items retained are the same. The construct retained are the same. The algorithm that you use are the same. The missing value treatment are the same, and so on. So this is the step 1 purpose that you need to fulfill, which is considered configural invariance. Okay. And in step 2, we run the permutation test and check on the correlation value. What we want, the correlation value must get as close as to 1. If it's less as close as to 1, or if it's no significant means there's no differences between the correlation composite score of group 1 and group 2, then we can compare it, and this is what we call compositional invariance established as partial invariance. Okay. And the step 3A and 3B, as what I mentioned just now earlier, we run the equal mean values and also equal variance. What we want is to check there is no difference. Okay, there's no difference between two groups regarding their variances and mean using logarithm of the composite variance ratio. What we want is to check there's no difference, and how to know whether there's no difference? We need to make sure it is not significant. As you can see in the confidence interval, there's no significant because negative and plus. So when it's no significant, then we can assure that there's no difference in terms of the variances as well as the mean value. So therefore, there are criteria for you to check on how to proceed before multi-group analysis. You need to check on whether your data itself produces partial invariance when you want to compare group, or maybe full invariance. Okay, these are the things for you to read on your own. So my summary of MICOM on measurement invariance is very easy. First of all, you need to check if step 2 and 3 both return findings of non-significant. 3 mean here 3A and 3B, which mean the mean and the variance. Then we can call full measurement invariance, because 2 and 3 show no significant. When no significant means no differences in terms of the no differences, and then you can compare. Okay, so when you know differences, you can compare. Then we call full measurement invariance. If step 2 you find not significant, but step 3 either one, okay, either one, whether composite variance or composite mean, either one is significant, then we call partial measurement invariance. Okay, but if only step 2 return findings is non-significant, step 3 all fail. Step 3 mean all significant, mean they show that there's a difference, then we call it partial measurement invariance. Again, I'm not a big fan when you do a MICOM, you check into p-value, because p-value result could be very false discovery result, because when your sample size is large, your result could be biased because small standard error. Therefore, I encourage people to look into confidence interval when you read MICOM results. Okay, but right now I think the smart PLS have corrected that issue. So regardless small or large, I think they produce quite same regarding the confidence interval and the permutation p-values, if I'm correct, because the last time tends to be a bit weird, the result. Therefore, I encourage people to look in confidence interval when you run the permutation test. So that's all. Let us try the technique on performing this measurement invariance. Any question on measurement invariance? Is the very easy question. not say very easy, but the clicking process and yeah, the understanding is like, very simple. Yeah. Any question before we move into the application of it? You can throw your question. What's the purpose? Okay. Eileen, the purpose is, sometimes when you do the moderator test, you want to see whether there's difference between two groups, and this moderator, you assume it moderates all the relationship that you have in your model, right? So if you want to assume that your moderator moderates all the relationship in your model, and you use like a variable called nationality, right? International versus Malaysian. So international versus non-international, compare the groups, right? Before you compare the groups to moderate all the relationship, you need to check on measurement invariance. Why? We need to assure their understanding of their items, of the items that you use to measure using survey, they are actually have the same understanding. When they have the same understanding, then you need to perform this measurement invariance, yeah, to check on it. Yeah, that is my answer to Eileen. Okay, any more question? No question. No question.
Yeah, we can proceed, Jacky.
Okay. To run this measurement invariance, very easy. I will go back to my smart PLS in a second. Yeah. So right now we are in smart PLS. Let us use the extended model, which is a bit more, fancier, more big, more complicated model. So this one I save first. I clean the data first. Yes. Okay. So we're gonna use this model. This is extended model in PLS, where we're gonna have quality performance, corporate social responsibility, and attractiveness as your exogenous point to competence and likability. From there, competence and likability point to satisfaction and loyalty, and satisfaction point to loyalty. And if this your model so complex, so you want to study, there's a moderator in this group, right? For example, looking to our data set that we have here, we have, for example, this called service type. Okay, service type could we have like prepaid and postpaid, right? You go to telecommunication, teleco company, you can actually apply for prepaid and postpaid. So from this prepaid and postpaid, so right now the first process before you run this multi-group analysis, you need to check for the measurement invariance, right? So to check on this measurement invariance, Harem,
Yep.
you can you see my screen, Smart PLS? I don't know whether I'm in the Smart PLS right now.
All good.
All good, huh? I'm very later I missed out. Okay, so we are running measurement invariance before we actually run the multi-group analysis. So the steps to run the measurement invariance are very easy. So first of all, in Smart PLS, you go to your data set and you can generate data groups. Like for example, I generate a group here. I need to find service type provider, which is service type, not provider, service type. I click this two unique value because we know there's two group of people, and I click OK button. When I click OK button, you have group 1 and group 2, okay? We have group 1 and group 2. So right now, group 1, for example, maybe we call it as prepaid, or maybe group 2, we call it as postpaid, okay? Prepaid and postpaid, okay? Example. So you can either rename it or you don't want to rename it, but just now, I just want to keep it like that. I just want to keep it like this so that you can see service type, we have group 1, service type, we have group 2. So in such a case, we go back to our model. In our model, before we run this multi-group analysis to see whether differences in every path, we need to check on permutation. Permutation is actually your MICOM, measurement invariance. So we click on this permutation test. From here, you can choose either group 1 and group 2. Okay, you can choose either group 1 and group 2. And then you just hit the button start calculation. Need some time because need some time, because permutation I run 1000, so it needs some time to generate the result. What I show you just right now is straight away jump to step 2. The step 1, which is configural invariance, I do not cover. Why? Because configural invariance is like you have two groups of data, but I'm going to show you also. So you're going to have two groups of data for that particular model. So we need to check that the retain of the items, the construct, the usage of the algorithm of the first model must actually same with the second model. Okay, so I'm going to show you the result soon, but let me run this permutation step first. And the result will be there soon. Give me a second. Okay, here you go. So before I go into the result of permutation, you see when I set the segment 1 and segment 2, I have two groups, right? Okay, you see I can have two groups, right? Segment 1 and segment 2, okay? So I have segment 1 and segment 2. If I change the segment 1 and segment 2, the result will be different. So what I'm going to highlight to you is the first step, of course, you check for your PLS algorithm, right? So you check for PLS algorithm, and then from here, sorry, I need to do something first. When I run your PLS algorithm, your data group is here itself. You need to click on group 1, group 2, and then you click start calculation. So from here, when you run your results, you need to check for your reliability. Like for example, I'm checking AVE right now, right now, I'm checking AVE. On your left-hand side, you can see I'm checking AVE. So from here, you check on group 1. You see your group 1, your AVE pass or not. And then you check on group 2, your AVE pass or not. Then you check on the loading itself, whether your loading pass or not for group 1, group 2, and so on. So this is the process of step 1. You need to check on whether the item that you retain in group 1 must equivalent with the items or construct that you retain in the group 2. You need to check, okay? So once you fulfill this, of course, you go to your permutation test just now. In your permutation test just now, the first step you need to do is you get your permutation test result, you click on MICOM. When you click on MICOM, what we want to see here is something like this. Step 2 and step 3. We check on step 2. In step 2, what we want here is your permutation p-value must not be, must not be significant. Must not be significant. In other words, you must get insignificant result. Insignificant result shows that when I use, for example, the first construct called attractiveness, when I have a construct called attractiveness, the group 1 and group 2 attractiveness are actually the same in terms of the correlation composite score. In terms of correlation composite score, which means their score, when all the items form into a score, their understanding of the both construct about attractiveness for both groups, they are the same. So it is not significant, means there's no significant difference, they are the same, therefore this is fulfilled, permutation p-value. Okay, so if this all fulfilled, you can see green color here is all not significant, then you can move to step 3. In step 3, when you run, this is the mean, okay, and this is the variance. What we want is to make sure your p-value for permutation p-value for the mean, this is the mean, and the following one will be the variance. So what we want, everything here not significant. But in such a case, in these results, you can see that the mean fulfill step 3A, but the 3B fail because there's one significant. When it's failed, then we can strongly highlight that this model itself, it is partial invariance. When you fulfill partial invariance, then you can actually perform the next step, which is called the multi-group analysis, which is you can perform to compare whether there's a difference between two groups to run the multi-group analysis. So that's it about the step of measurement invariance. So I have shown you how to do the MICOM procedure when you want to check on the measurement invariance. So what if things doesn't work out in MICOM? If you have group data and you really want to run multi-group analysis and you fail in measurement invariance, okay? Especially you pass step 1, but you fail in step 2. Minimum requirement is you need to fulfill step 2. So if you fail step 2, what you can actually do is like you check on your every observation or cases, right? You can check on straight lining or maybe check whether there's a standard deviation issue. The second thing is your measurement model, okay? You check, sometimes your reliability is bad, your loading is bad, your validity is bad, check on those. And then if you use a reflective construct, because reflective construct, the indicators are interchangeable. Therefore, if sometimes you fail in your MICOM, you can delete item that talked about reflective construct, only reflective construct, in order for you to pass at least minimum step 2. And the fourth will be change the latent interaction effect maybe to categorical or dichotomous moderator, which means you test it, don't do multi-group analysis anymore. Maybe you do latent interaction effect. And this could be the last resort for you to do like latent interaction effect, like product indicator approach, two-stage approach, and orthogonalization approach. And the final last resort, which is the worst, will be drop the construct if you never fulfill MICOM, okay? But it is not advisable for 5. 4 also not really that advisable, but first, second, third is the most advisable, okay? If you want to read more about this measurement invariance on how to step-by-step run before we go into multi-group analysis, you can read this article. You can read this article also. That shows you how to do this measurement invariance before you perform the multi-group analysis, okay? For further reading materials, of course, these are the further reading materials. And yeah, join MySEM. MySEM got everything that you want to know. And I forget to include, we have our YouTube channel on ResearchLand. So if you're interested, you can actually, subscribe to ResearchLand, and you can see a lot of cool stuff about quantitative research, qualitative, and so on. And that's it. If you've got any question, you can feel free to text me.
All right. Any last words from you, Jacky?
I hope the 4 session will not confuse you. And I hope you enjoy it. And yeah, if you've got any problem, you can feel free to email to me. A humble advice from me is just do your part, play your role, do your research. and keep on learning, keep on reading, be open, and yeah, don't just follow just one side, open and see how things work out. Because what I preach today could be wrong tomorrow, today. So because there are new literature coming in, so yeah, keep on learning and abreast yourself with new knowledge. That's my answer. Yeah.
Yeah, thank you, Jacky. I think it is important to understand, to put things into the right perspectives. These 4 sessions are about 4 specific topics. So Jacky did not really go through everything from A to Z, but of course there might be other workshops, or we might plan workshops in the future to guide the participants in a more comprehensive manner. So throughout Jacky's discussion, I hope we are all impressed with the fact that it is a continual learning process. It is more than just clicking. It's about understanding the mechanism behind, the reasons behind. There is no one formula that fits, that applies to all situations. You still have to look at your objectives, the nature of your research problem, your data, the characteristics of your population, your data, so on and so forth. So continue read, continue learn. Jacky email will be made available, so feel free to get hold of him. Join MICOM, as he said earlier, this is where we will continue learn and discuss. So if there is no question from the participants, we will end our session today here. All right.